Welcome back. This is another one of our videos. If we just talked about physical and chemical changes. So if you need these definitions again, I have highlighted them again. You can pause the video and copy them down. What I need for you to do for this video, because we are going to talk about mixtures and substances, pure substances. So if you would please, you're going to copy down some notes, and at the end there is going to be a diagram that I need you to copy down into your journal. Okay, so let's get started because this one's probably going to be a little longer than the last few. All right, so we're going to be able to categorize samples as matter or as a substance. Or mixtures, I'm sorry. We're going to distinguish between homogeneous and heterogeneous samples of matter. We're going to describe two ways that components of mixtures can be separated. And let's jump into this. All right, mixtures are physical blends of at least two substances, have a variable composition, and they can be either heterogeneous or homogeneous. Okay, so I need you to copy down. Let me make sure I have my highlighter on, and so I can help you out here. Okay, so I need you to have that mixtures are a physical blend, have at least two substances, and they can either be heterogeneous, which means they are not uniform in composition, which means that you see more than one thing in the substance. So a chocolate chip cookie, gravel, soil. In a chocolate chip cookie, you see the chocolate chips, you see maybe the walnuts that are in it, you might see the dough, okay? In gravel, you see different types of different size pebbles in there. Soil, you might see some bugs, dirt, okay? Just different things. Okay, homogeneous means same composition, okay? Heterogeneous means different. I don't know if I can do this with this one. Different. Because hetero means different. Homo means same, composition throughout, okay? And they're also called solutions. Solutions. Please make sure you copy that down. Kool-Aid is a solution. Air is a solution. Water is a solution. Salt water is a solution. They're homogeneous mixtures. That means when you look at Kool-Aid, all you see is the red Kool-Aid or the green Kool-Aid. But it does have sugar in it. It has water in it. And it has food coloring in it. So it's all mixed together, but all you see is the Kool-Aid. You don't see anything else. If you put ice in your Kool-Aid, now you have a heterogeneous because you see the ice and you see the Kool-Aid. Okay? Air is a solution. Gases can be solutions. All right. Every part keeps its own property. All right. So mixed molecule by molecule, thus too small to see the different parts. This is more of a solutions mixture. So you don't see that all the different parts. It's too small. Can occur between any state of matter, gas and gas, liquid in a gas, gas in a liquid, solid in a liquid, solid in solid. Okay, this part right here, please make sure you have some kind of idea what this is if you're not going to write it down, which I would suggest you write it down. When you have brass, you have a solid and a solid, you have alloys. When you have steel, steel is not an element on the periodic table. It is an alloy. It's a mixture of multiple metals, and that it is a solution. Okay. Based on the distribution of their components, mixtures are called homogeneous or heterogeneous. Okay, so those are those two words again. All right, phase. The term phase is used to describe any part of a sample with uniform composition of property. So a homogeneous mixture consists of a single phase. Okay. A heterogeneous mixture consists of two or more phases. So single phase, homogeneous. Two or more phases, heterogeneous. Okay. Or heterogeneous if you want to call it that. Some people have said that too. Or homogeneous. Okay. I'm going to skip that part right there. Separating mixtures. Okay. All mixtures can be separated at some point. Some can be easily done and some cannot be easily done. You can do it by physical means. Rocks and marbles, iron filings and sulfur. You can use a magnet. Differences in physical properties can be used to separate mixtures. So filtration, separating a solid from a liquid in a heterogeneous mixture by size. So there's filtration, okay? There's physical properties to separate mixtures, okay? So physical means. Filtration, if you ever have, what is it? Your pool has a little filter system. It has different parts where it can catch different size particles. That's by size, okay? All right, we can also do paper chromatography. This is the one we're going to do in class. It's components of dyes such as inks may be separated by chromatography. So you know how you have that blue and yellow make green? Well, here's how we can figure it out. This chromatography is also used in pregnancy tests. It separates out the hormones. So chromatography can be used in multiple ways in the real world. Distillation, this one takes a little bit more time, and it does take advantage of boiling points. Okay, boiling points are physical properties. Remember I told you in class, I think I mentioned it in a couple of the classes, that if you have a metal, you can melt it down, and at different melting points, the different metals will separate out. Same thing is here. If I have water in here, I can heat it up, and water will boil at 100 degrees Celsius. So the water vapor will come up, it'll go in through this tube, it'll cool it down because you have water cooling it, and then you get pure liquid water over here. It's kind of how it works with the water treatments contraptions that they're using in different parts of the world to give them fresh water. That's one way, not the only way. There's other ways too. Okay, so elements and compounds, because we talked about mixtures. Now we're going to talk about elements versus compounds. We're going to explain the difference between element and a compound. Okay, we're going to identify the chemical symbols of elements and name elements given their symbols. That's why we have this element tests off the periodic table. Substances are either classified, and this is substances. Okay. Substances are either going to be elements or compounds. Elements is the simplest kind of matter, and they must be on the periodic table, guys. Elements must appear on their simplest kind of matter. They cannot be separated anymore. Cannot be broken down into simpler, and they still have the same properties of the element. All one kind of atom. One kind of atom. Okay. Compounds, I don't know if I said components earlier, but I meant compounds, sorry. Compounds are substances that can be broken down only by chemical methods. So compounds are like water. I cannot get hydrogen and oxygen to separate without a chemical method. Okay. When broken down, the pieces have completely different properties than the original component. That's kind of important. Okay. They're made of two or more atoms, chemically combined, not just physically combined. So they must be chemically combined, such as carbon dioxide, water, carbon monoxide, sodium nitrate. Okay. All right. Compounds. I'd copy this in your journal. You can pause the video. Okay. Compounds made of one kind of matter, made by one kind of material, made by a chemical change and definite composition. That means they come in a ratio. Okay. So make sure you write that word ratio right here. Ratio. Okay. Mixtures made from more than one kind of material, made by a physical change and a variable. They have come in variable composition. So they can be like your pepperoni pizza. You may get a lot of pepperoni sometimes. Sometimes you may not get very much. So pause this if you need to copy this down. Which is it? Okay. So I'm going to tell you right now, we're going to be doing an activity with these dots. So if you have just dots of one color, it is an element. Nothing attached to it, just one dot, it's an element. Okay. What is this? This is a compound because you see they're in ratios. It's a 2-to-1 ratio. 1 green to 2 black dots. Okay. Oops. This is a mixture because we have big black dots and little green dots, and there are no composition to it. Okay. Elements versus compounds. Compounds can be broken down into simpler substances. Elements cannot. The chemical change is a change that produces matter with a different composition than its original. So again, here comes all that stuff again. Okay. Make sure you have that somewhere in there. I wrote it down a few minutes ago. Chemical change, a change in which one or more substances can convert into different substances. Heat and light is evidence. Different properties that can then the component elements. Okay. Due to a chemical change, the resulting compound has new and different properties. So table sugar is going to turn into carbon, hydrogen, and oxygen. Sodium chloride is going to turn into sodium and chlorine. Water is going to turn into hydrogen and oxygen. Okay, this is what I was talking about. So stop the video, and all matter can be separated, or all matter can be either mixtures or pure substances. Okay, so here's your questions. Can it be separated by physical means? If yes, it's a mixture. If no, it's a pure substance. Okay, then you ask yourself, if it's a mixture, is it uniform? If yes, it's homogeneous. If it's no, it's going to be heterogeneous. Okay, so if you're a pure substance and it can be decomposed by ordinary chemical means, if it can, it's a compound. If it can't, it's an element. Also, if it's an element, it's going to be on the periodic table of elements. Okay, so pause the video, copy this down in your journal. All right, we're not going to worry about this. We're going to stop there because I'm getting pretty long. So make sure you have this in your journal. It's very important that you know what kind of matter we have. Okay, guys? And I'll see you tomorrow in class. Have a good day.